So this grew out of a careers guidance poster that we used to have, which we used to take to school fairs and provincial fairs. And it had a little picture where kids were asked to sort of point at anything that sort of grabbed their fancy. And from that, they would try to get some idea as to where the kid's heart lies. Whether you've been in a farming community, whether you wanted to be a fire engine driver, or whether you want to be a pilot, or whether you wanted to be a... So I used to point at that. And we said, we need something a bit more modern. And the dream was we would build a game, like the Game of Thrones. And instead of walking around and being attacked by transformers, you would be able to see the real world, or the virtual world, and you would be able to look at things, click on them, and they would explode to reveal their construction. As we say, the inner world revealed. So our classic starting point these days is the car. And you would see a car on the landscape, you would click on the car, and then it would reveal all its components, from the tires to the fuel tank, to the braking system, to the exhaust, and right up to the engine, to the power unit. And when you click on the power unit, this is where it gets exciting, because now we introduce animations and we show you what's actually happening inside the engine. We have a label diagram on the left, which gives you a bit of a clue as to what the various parts are. And then we normally have a photograph of the real thing just to show you what it looks like. And then there's a short text, which is just the basic, just to get a youngster interested in the subject. And again, we've kept the text to a minimum because of language issues and literacy issues. So the drive here is to have an animated world that somebody can explore at their whim. Now, I might as well mention it while we're here. The mathematicians have said, so how do you cater for mathematicians inside this wonderful STEMulator? So what we do on most pages where we can, and we're still looking for content for some of the pages, we have the square root of X sign, and there we bring in some aspects of the car. This one happens to be the engine geometry and the swept volume of a cylinder and the compression ratio of an engine. And then if we have organizations that are associated with us, we would carry their logos down here. We're getting very friendly with Wikipedia, and we're hoping eventually to really cement that relationship. And then we will take you through to the more detailed text that is available within Wikipedia. Now, for that feature, you will generally need to be connected to the internet. So that, depending on the volume, could or could not be on the memory stick. And then over and above that, we have a video which also introduces some aspect of the car. And these are being curated from content that's available on the web, and they play out. And that material is actually embedded in the memory stick, so that is available. Then right at the bottom of the page, unfortunately my taskbar is getting in the way, we have a list of let me shrink this down a little bit. We show you the various careers that are closely linked to the car engine. This one happens to be a mechanical engineer. There's a description there, quite wordy, about what mechanical engineers do, what they get involved with. And then we show you where you can study in South Africa. And there's a whole list of universities that offer you mechanical engineering as a subject. And the University of Witwatersrand have given us a small contribution, so they get their logo and crest, and they also get the click-throughs go to the direct page that is relevant to mechanical engineering at BITS. The other universities, you go to their front page, and from there you must work your way through their website to find the appropriate page. So back to the car, back to the mechanical engineer. So that's one aspect. Then if I get out of here, I'll go and show you something else exciting, which is a human being. And again, you click on the human being and he also explodes, or he as it happens, explodes. Then we can reveal the muscular side of the human body. We can reveal the skeletal side of the human body. And again, for every one of these, there are a whole list of professions that you consider embarking on. And from that, we'll also guide you with your subject material and places where you can study in the country. Right the way through to the digestive system. And here's quite an interesting thing. The world is full of YouTube and 200, 500 megabytes of bandwidth gobbled up with a video clip that spends half an hour explaining why the guy is the world's expert on who he is, talking to you, and about 10 seconds actually showing you what you wanted to look at. So we worked very hard at trying to find content which is compact GIFs, which will cram inside that memory stick. And this one top right here is our favorite because it was one of our first ones that we came across. It's a 28 kilobyte GIF file, and it does the job of explaining what goes on inside the human digestive system. So there's a label diagram on the left, and there is some sort of X-ray, color enhanced X-ray to show you what the thing looks like in real life. We also have the pumping heart. It's another one of our favorites. Nice animation, again, label diagram, an animation showing what goes on with the blood backwards and forwards, and then a photograph of a real human heart. And on the left, the plumbing diagram for the human body, from the blood out to the returning blood. So we decided to embark on 10 major areas which are of general interest before we got into anything more specific. And we have an aeroplane in the sky there. We thought that's something that people would see but don't have much opportunity to get inside and to have a look at. And we take you through to the cockpit. We explain the controls that are available to the pilot on the plane and how it makes the plane lift and turn and pitch. We have a whole agricultural section. Now, here's one of my favorites because I saw something quite strange the one day, and it was a machine that gathers whole olives off olive trees. And I hadn't stopped to think about it, and I've never seen one. And I tripped over it on social media somewhere. And a month later, do you think I could find that clip that I'd seen? It was vivid in my mind, but I couldn't actually find out which platform I'd seen it on. And when you go back to that platform, you can imagine that it's gone 200 pages down from the last time you looked at it. And so one of the big advantages of the STEMulator is if we see something that we like, we can put it where it belongs. Now, what I mean is we've taken you to the farm, we'll take you into the orchard, we'll take you into the olives, and there you will find this olive harvesting machine in the top right. So if you've seen something and you know where it belongs, go to the STEMulator, it will be there. You won't have to go and do a Google search and find what words you should use and then filter through all the dilution that goes on the internet these days. And Google, unfortunately, has got a very commercial angle. So the things that come to the top these days are in the marketplace and not in the technical domain. So we worked hard to actually go and find that content that belongs in the of general interest and of educational value. So that's my favorite olive harvesting machine, which is where it belongs. So we also have on the other side, we have ground crops and we have wheat. And I'll mention this because now what we want to do is we want to say, well, here you are looking at wheat. This is great. What happens to wheat? Well, we make it into bread. So we're hoping we're going to build a timeline. And what will happen when you go to the house and you go into the kitchen here, at the moment, the menu here offers the appliances, and we're slowly populating the STEMulator with details about various appliances. But we're going to change the pantry. That's a kettle. So we're going to change the pantry to reveal the contents, and in there will be a loaf of bread. So depending whether you start with a loaf of bread and you want to see where it came from, or whether you start in the wheat field and you want to see where the wheat ends up, we will have a timeline taking you through from the wheat, through the threshing, through the bakery, out through the transport system and into the home. And all of those aspects are going to be covered in the STEMulator. So we've got a transport tile here on the left for the bridge, and that will eventually reveal all forms of transport. You can see the train there, the planes up there in the sky. There's a helicopter here sitting over the top of the hospital. So all of those will liven up to show you the whole spectrum of transport. Oh yes, and there's a container ship out there in the ocean. So they will show a link between the various modes of transport and how they cover the world to move goods around. This construction site here, we basically introduce you to architecture and construction. So here's another angle covered here. And then next door, we've got a garage, which is now going to become our factory. So on the Mark II, which we've got on development, we now have a factory, and that will take you through various aspects of factory, be it a bottling for milk or for orange juice. And again, you can imagine we've got oranges in the orchard and we've got orange juice in the fridge, and we'll take you through the whole process. We've even got a car production line. So if you click on the car, we'll show you how that gets put together in the factory. And again, with the bread, we'll show you a baking process. We've got pharmaceutical packaging. Those are ready for release in the next month or so. So that's the networking that goes on there. And then the school is also on the drawing board right now. And we want to cover the full curriculum. Now, what are we hoping to do here? A lot of these schools in remote areas are aware of the curriculum. They want some way of actually demonstrating it to their pupils. And maybe the topic happens to be green energy. So their classroom, in fact, let me just show what a classroom is going to look like. This is quite nice. So once you get inside the school, you'll be taken into a classroom, be it for intermediate phase or junior phase, and you'll have the maths classroom and you'll have a science classroom. So as you look in this room now, you'll see on the left-hand side, we have a skeleton with some of the contents of the human body. That will obviously take you through to the pages I've just shown you. Then we've got the sun here with the planets whizzing around. That will take you to the page that has that material, which is on the top of the STEMulator. Then we've got things on the side. We've got minerals here, which are to do with the rock cycle. And what we'll do with that, we will take you into the mountain, and you'll see there the rock cycle that goes with that. So the school will produce the curriculum material or the content for that particular age group, but the actual STEMulator will then host the various aspects. Here's weather, so aspects about clouds and that. And if we go down to rain, then we've got we introduce the water cycle, which is evaporation of large areas and the precipitation from clouds, and that whole cycle goes round and round and round. And we also talk about global warming here. We don't do yet, but this is where we'll introduce global warming. We've got meadows here, which we're going to introduce some aspects of biology and insect life, which we have a contributor for. And on the right here, we've got a forest, which is, again, waiting to be populated. Here's the sun, obviously something of interest to people. They can see it, but they can't see what's inside it. So again, we reveal that information within the STEMulator. So in this short time, you're going to cover quite a lot of ground within the STEMulator. Where was I last? Oh, the hospital. Here's another one. So here's a place people don't want to see inside of unless they can help it, but should they? This is what goes on inside there. And here we've got a consulting room. We've got the ICU unit here, which explains all the machinery that goes on inside here to look after you while you're in intensive care. We've got ultrasound here, so we can introduce the subject of scanning of babes in the womb. I've got the sexy MRI machine here, which is quite nice. This shows you the inner sides, all these magnets spinning around, and credits here to Toshiba, which is where we got the material from. We're also trying to build up a relationship with other suppliers of hospital kit, and anybody else who has content that they feel they would like to contribute to add to the STEMulator to enhance it. We're only too ready to accept the material, because this is only as good as we get the content, and sourcing the material is quite a time-consuming exercise. So we've embarked on a relationship with quite a few of the professional societies within NSTF and proSET. And basically now that the STEMulator is mature, we're saying, guys, surely you want youngsters to come into your profession. You guys at university, you've got material that you use to describe concepts to people. And we're only too happy to host it, provided you're happy to share it. And it's all in the common good of getting kids back into the STEM, or not back into, but to guide them in the direction of STEM and expose them to things that they possibly haven't seen and probably haven't even had anything to get excited about, apart from seeing its functionality in terms of being used in the world. So here now we get to sort of show you the inner workings, and that tends to generate a new level of enthusiasm and an interest in the subject. So I don't know how much time I've been taking, and I had an early start. So who's chairing? I'm sorry, I arrived late.
I'm chairing, Richard. You can go on, because we have a bit of a break in the program. One of our speakers cancelled.
Oh, okay. So Okay, well, maybe I can start looking into our crystal ball and getting excited about a few other things that we are experimenting or embarking on. So we recently introduced what we call the Science Plaza. And this is now to try and accommodate things that we've got a nice relationship with a crowd called the South African National Biodiversity Institute. And they were keen, they've got lots of material that they're proud of. And they actually chose the STEMulator to be the host for their material, which is quite an honor for us. And we're actually quite excited about this. But that caused us to basically build the Science Plaza. So anybody who's been to Washington have been to the Smithsonian Institute, I pictured this whole terrace where you've got all the museums scattered down along a long road leading up to the Capitol. So we've now created here, we've got an animal world at the top end, and that will link through to various animals. At the moment, we do it with icons, but we actually have an animal world, a zoo layout that we will portray, which will actually then host a whole variety of animals, and that will take you through to their real habitat. So we will take you to ice caps in Antarctica, we'll take you through to the plains of Africa, we'll take you through to wherever these animals belong. So you'll see them as a starting point in the animal world, but the connectivity will take you through to their habitat to show exactly where they would normally live. Then a funny story is that we heard from the biodiversity people that they wanted a herbarium. So I thought, great, so we'll build this nice conservatory here where plants grow and we can house specimens from all over the world. And then the ladies came back and said, I've got news for you. A herbarium is actually pressed flowers and pressed herbs that are preserved in almanacs. So we need a museum. So bingo, we've made a museum. And just to give them the credit they due, so here is a pressed flower collection. And here's a process of where they gather the specimens and then archive them for posterity. So they've got archives of foliage that are 100 years old or so that have been collected from the early days. And that actually what a herbarium is, and that gets one room in our museum. So again, we're going back here, we've got the botanist. We tell you a bit about botany, we tell you where you can study it. So every page where there is something happening, you will find a careers guidance, which is one of the focuses of today's gathering, is to actually, how do we stimulate people or stimulate people into careers in the STEM world. So here's Sanby, here's another good example. So they now are a partner, they're endorsing what we're doing. In fact, we're hosting them. And if we click on there, we actually go through to their website, where they actually have some content there. And here's the National Herbarium and the description of what goes on there. So we want to build up on these relationships and these partnerships. So the STEMulator is free, it's out there. I like to think of it as Wikipedia, I really do. I want people to come here freely, willingly, no advertising, and they can find connectivity to anything to do with STEM in a very convenient and a very well laid out and a very appealing, satisfying experience in terms of mobility and exploring. So I want to just show you what the museum is going to look like, because we're quite proud of this next chapter. So we built this little doll's house, and we're going to replace that chandelier, by the way. We've got something more exciting for the science world. And so these are the various rooms. So we've got the microscope for those funny, creepy, crawly things. We've got the larger version here. Then we've got fossils. We've got the history of mankind here. We've got transport, because museums have transport divisions, but guess what? We'll take you off to the STEMulator's own transport components, but just to make the museum complete. Then on the other side, we've got some rock samples here for the geologists. We've got the solar system here and the planetarium. We've got the herbarium, which is here. We're going to put a nice bookcase, an exotic bookcase with all their volumes in there. We've got a military division in the bottom right here, and then we've got robotics here on the bottom left. So those are the subject material we hope to house within the museum. We've got the observatory here. That's the next thing to be populated. We do have on the main page, we do have a satellite. So we do have the starting blocks for satellites. That will start talking to cell phones in the home and start showing how satellites are involved in transmitting messages around the world and involving with the communication and with the television set as well. That's also part of the repertoire. So one thing we've also got here, which has been here for a while and is a bit slow to populate, is the mine. So if anybody sits here today is involved with the mining industry, we would welcome you. We've seen the animations, we've seen them, we've seen these models of machines running around underground, digging holes and blasting rock and taking it to surface. We got them, we're basically preparing them, and eventually this mine will come alive. So, Yancy, do we have a mechanism for questions? Is it sort of keep the audience alive and awake? Should we offer them some opportunity to ask questions?
Yes, perhaps I can just add to that. Thank you both, Richard and Kgaugelo, for your presentation. But maybe I can just mention that we've got a partnership with South African Institute for Industrial Engineers as well. I think you did briefly mention that, but I just want to emphasize that. And that is for a factory tile. Mm-hmm. So we'll be having various types of factories that that produce goods, and they will then be transported through the transport tile. Mm-hmm. And then we've got KBK Engineering, who is helping us with the, well, that's the transport, with the transport tile. So the bridge and train and things like that.
I'm going to give you a flash of the factory. I just need a second to find the email because it's actually quite exciting.
While you're busy with that, we also appealed to our members to provide content, and among others, we got some material from the Corrosion Institute of South Africa, CORISA. And so you'll see on some of the relevant items, there is an icon where you click and you learn about corrosion. So, for example, on the car's exhaust, corrosion is an issue, and you can click on that and see.
Right, here comes the factory. This is a little MP4 put together by the developer. It'll just give you a taste of what we have in mind. So we look at electronics, motor vehicle, aerospace, textile, pharmaceutical, and food. There's a plane section. We just had the car. Here's the plane being assembled. Here we're now in fabric manufacture. These are a weaving machine. Here we have pharmaceutical filling on a bottling line. And I think this is a bottling for juice. So I show you how the bottle is made. And a quick view of containers being loaded onto a vessel to go to foreign lands and some internal warehousing. I'm just flashing this by you. These are the sort of development process of clearing your brain, putting some ideas down, and then eventually constructing them to fit inside the STEMulator. And that will replace the garage here, and that will be a factory which will then link out to the transport network. Then I think you're as up to date as you can be, because that really is the full spectrum of the STEMulator as it stands at the moment. But it's taken on a life way beyond what we had in terms of just being something to guide kids in careers. It's almost like a bedside book of how things work. And we're building up relationships with a lot of these organizations out there. We are not trying to do anything new apart from the STEMulator being what it is. The rest of the content exists. It's just a matter of going out there, finding the partners who've got good quality material and getting their buy-in to share the platform with us. It's free. It's not going to have any advertising. It's going to be available to the world. Although we're talking in an African content, this is as worldwide as Wikipedia would be. There's no reason why a kid in South America or North Europe or India can't dial into this. And unfortunately, at the moment, it's in English only, but I don't think it's very difficult for the larger developers to put in a language but and have automatic conversion to the local lingo. But the appeal of this is the visuality and the what do they call it when navigation? The fact you navigate yourself through the actual world itself. You actually go and look on things, and we connect you with what belongs connectivity-wise, like the wheat gets to the bread and the cow gets to the milk. So all that connectivity is built in here. So talking to one of the teachers at a online school, they said this is quite nice because what they do psychometric testing for the sort of the grade 9s and 10s. And beyond that, they said, imagine if we gave the STEMulator to a youngster and you can build in an analytics function. So we would say to the kid, go and spend half an hour going to the STEMulator and see what takes your fancy. And then when they're finished, they would come back and they would get a report as to whether the kid spent time in the human being and the hospital, or agriculture and nature, or whether they went to the motor car and the aeroplane. And that would give those careers guidance people another angle in where the kid's interest lies, which doesn't necessarily come out of a psychometric test, a classic psychometric test. So there's something we never even thought about that's been asked of us to enhance the STEMulator, to make it useful in that field. And I guess the other thing we're also exploring in terms of appealing to kids of this age group is we're probably going to start putting some buried treasure around, or have scores on various pages. So the more pages the kids visit and the more complicated the page is, the higher the score they will achieve. And hopefully we can add content faster so they can visit all the pages. So it'll be the carrot will be always ahead of the individual. But those are just the ideas we have. And but it's a very exciting project, and it's got remarkable application in exactly the forum we're talking about here of getting kids into STEM. And I keep talking about making sure we have a pipeline of youth for the future, that the kids are not just wanting to be managers. Their role models aren't just Elon Musk and Bill Gates, that they actually can come down a notch and relate to their engineering fathers and uncles, to the doctors and other people who've got professional responsibility. So Yancy, I think I'm drying up. I think I've covered most of the things I normally get to say. So yeah, I'm happy to feel.
Thank you, Richard. Yeah. Any questions from the audience? Anything else you want to add, Kgaugelo?
I think Richard has said a mouthful, and I wish I, growing up, had the STEMulator. It would have helped me out quite well there, because I was quite confused as a young person, and I had good grades, but I just didn't have anyone else to guide me into particular streams or pathways. So for me, I am biased. I do work for the STEMulator, but I am quite excited about the platform and how it can help teachers, learners, moms and dads who just are going through homework and they want content, for their kids' speech or whatever it might be, and they can all find it on STEMulator. So yeah, this is just a glimpse of what the STEMulator can do for the future of our STEM professionals, yeah.
Okay, thanks, Kgaugelo and Richard. This is a proSET project. The proSET committee is responsible for overseeing it, and also provided the initial funding that was necessary to build the STEMulator. So I just want to give that credit there where credit is due, and especially because this is a proSET discussion forum. I think there are a number of issues that that we can discuss also from yesterday. So I want to get your response about what Dr. Ian Mole said about the curriculum amendments in terms of robotics and coding. So if Kgaugelo, do you want to say something about the STEMulator or in response to my question?
No, yeah, thanks, Jancy. I think so much was said. It's not that we want to add anything of the content, but just to invite being part of the proSET committee or the STEMulator subgroup, just to say this is a living organism that will be as good as we make use of it. So if anybody in this team, you know, can give advice or guidance into which direction, what to add, then please, I think we must put maybe Richard's details just in the chat as well again, and, you know, take advice from anybody that wants to add to how to make this bigger and more alive. So no, thanks for that.
Thank you, Kgaugelo. Yes, that's important to say. Kgaugelo's email address is there in the chat. So you can,
yes, then it will go directly, and
yeah,
it can be.
You can contact Richard through her as well.
Thanks.
Okay.
Great.
All right. Do you think that we should add robotics and coding to the STEMulator?
I think Richard kind of gave us a glimpse of what the museum will look like, and in one of the little windows of the museum, you'll have robotics. And we're hoping in the school we'll also put in coding, you know, because I mean, that's what our kids are doing. And so it is something that should be part of STEMulator, because this is one of the routes that students can take. Programming, app development, being a game designer through coding. And it was fascinating to see at the National Science Week, you know, kids who were playing with the different robots there. And when you ask them, what do you want to be? It's like, I just want to build a big robot. You know, it's just true, but it's just so cute to see that. But this is part of their lives, you know, so you cannot be sort of outside of that. And I love the comment that Gordon put in the chat there, where he says, you know, how can we test ideas on how to implement the SDGs, you know, the SDGs, yes, in STEM lessons. And I think it's a good thing to consider. It's a good thing to start thinking about, because we need to create, you know, teaching concepts that encourage children to be active and responsible citizens using the STEM subjects, you know. So it is something that we are more than happy to discuss and welcome in terms of just how we can make the STEMulator an even better product for our learners.
Yes, thank you. On that note, I can say that we're working on a partnership with the Water Research Commission. They have a lot of materials on various aspects of water management. And of course, you've seen the lake on the nature tile. And if you click on the top of the mountain, you will see the water cycle. Yes. So it will be connected to that area of the STEMulator. And there certainly one can refer to the SDGs. Yes. It's also possible we can put the SDGs in the school and then have various links to parts of the STEMulator.
Correct. Yeah. Awesome stuff. If there's no more comments or questions, then thank you so much for everyone for listening.
Thank you, Kgaugelo. Kgaugelo says, maybe we can call it the Science Center, not only museum. No, Kgaugelo, remember, we've got the one little building on the tile is the Science Center.
Right, but she was talking robotics. We said we put robotics in the museum, and I thought I will look for robotics in the museum. But that was a fun comment. Yeah, sorry.
Okay, okay. We have regular discussions about where to put things and how to show them. Okay, about careers, career guidance. Oh, before I say that, let me just tell you what's going on with the program. I have requested Catherine Cure to give to talk in place of the next speaker, but in fact we've run out of time now, so we'll stick to the program, and the next speaker will be Dr. Kgaugelo Pule. But before that, Richard has just shared the Science Plaza again with the museum.
Yeah, and the Science Centre is that small building the bottom of the screen. That is a Science Centre. And what we'll do within the school, we also have a laboratory in the school. And here's another quick angle. Have I got 2 minutes, Yancy? Yancy, have I got 2 minutes? So in the school, in the
Sorry,
remote
yes,
areas,
you have.
the science teachers have the problem of whether they have the right equipment and whether the chemicals still work and whether something hasn't been broken. We don't need to worry about that anymore. There are video clips of every single experiment a teacher is supposed to perform on YouTube or on other platforms. And we've got a nice relationship growing with a couple of organizations. And I see we've got Derek Fish in the audience, and he has got some absolutely fantastic material for modern day education in science. And I'm not going to say anything now because that would be putting the cart before the horse, but the Science Centre in the Science Centre on the plaza and the laboratory in the school would all basically link through to the same. Those were the fundamentals of science and energy. So if you go back to the classroom here on the back wall, we've got electricity, the simple circuit, we've got states of matter and light. Now those concepts you can't really build into the STEMulator itself in terms of showing you something. So those will be conveyed either in the Science Centre or in the school laboratory. It'll be the same place. It'll just be two routes to get to the same material. So that's the plan there in terms of conveying basic science, fundamental building blocks of science and energy into the curriculum and housing it within the STEMulator. So I thought I'd just share that with you. Okay, that's me done again.